So let's use this stuff to prove that binomial random variables converge in distribution to Poissons in a certain sense. We've already seen this by looking at the probability mass functions for binomials, right? In fact, it turns out, this is probably the, one of the most natural ways to think of what the Poisson random variable really is. It's a limit of a binomial. When you take a large number of trials, and your success probability is really small. Okay, and so let's let x of n be a binomial random variable with n trials and success probability p sub n, so that we're letting our success probability depend on the number of trials there. And we're going to let p sub n go down to 0 and n go to infinity in such a way that the product of those two bad boys goes to lambda, okay? As n goes to infinity, some constant there, okay? Then, now we've already proved this result. We're just going to do it a different way this time. That is, what's the result? I don't even know. I guess what we're going to show here is that the moment generating function for this begins to look like the moment generating function for a Poisson as n goes to infinity. Okay, so let's try that out. So I'm going to just write down the moment generating function for x sub n. It's a binomial. Okay, so again, that's this thing is defined to be the expected value of e to the t x sub n. Now, actually, you know what? I know what that is. I can look it up on the web, and I know what that is. Actually, we derived this earlier in the class. But it's just p sub n times e to the t plus 1 minus p sub n. All that is raised to the nth power, right? Okay, so let's see. Let me pull my p sub n stuff together here. So another way I can write this is 1 plus p sub n times e to the t minus 1, right? Okay. Now, let's see. I'm going to come in here and be sneaky. So that's what I do. I'm going to, on this second term here, I'm going to multiply and divide by n. Okay. Now, what does this spell? Hey, look at this. You remember how if you have 1 plus something over n raised to the nth, as n goes to infinity, this starts to look like e raised to all this stuff. And in fact, there's another result that says that if all of this is moving toward a limit, then all of this is actually going to e raised to the limit of that stuff, right? Well, I don't want to do that. So what is the limit of n p sub n e to the t minus 1? That's lambda, right? This part is going to lambda, and then e to the t minus 1, right? But this is in fact the moment generating function for a Poisson. So there we go.